Using SOHCAHTOA to find angles. So let's recall the three trigonometry ratios. It's the sine of theta, or sine of an angle. So this is a Greek letter that's called theta. And it's just a symbol that's used to represent an angle. So sine of an angle is the opposite side over the hypotenuse. The cosine of an angle is the adjacent side over the hypotenuse. And the tangent of an angle is the opposite side over the adjacent side. And remember that when we are labeling our right angled triangle, always across from your right angle is the hypotenuse. And then the opposite and adjacent will change depending on where the given angle is or the angle that you're trying to find. So in this diagram, E is our given angle. So the side across from that angle is the opposite side, and the side beside that angle is the adjacent side. So when you encounter a problem where you have the lengths of any two sides in a right angled triangle, it is possible to use a trigonometry ratio to calculate one of the acute angles. And we do that by using the inverse trigonometry ratio, which you might see on your calculator as a little tiny written things above sometimes they're above your sine, cos, and tan buttons, which makes it easier for us to find, and sometimes they're in different locations. So you're going to have to look at your scientific calculator and figure out where they are. If you are using an iPhone as your scientific calculator, when you press the shift button, you can access those inverse buttons as well. So for every trigonometry ratio, there's an inverse ratio. So remember when we talked about solving equations, we looked at opposite operations. So this inverse ratio is like our opposite operation. So where we have addition and subtraction are opposite operations, and multiplication and division, when we even looked at squaring a number versus square rooting a number, well, taking the inverse of a trig ratio is the opposite of taking the regular trig ratio. So it's used to calculate the angles, and inverse operation ratios are usually found on a scientific calculator as a second function or a mode key or even sometimes a shift key, depending on what your calculator looks like. So take a look at your calculator and you'll see the inverse for sine is represented as sine to the -1. So this shows us that sine is to the exponent of -1. And when you get into exponent laws, you might learn about inverse or negative exponents. And negative exponents just mean that we are doing 1 over the sine. And so dividing by sine is going to be the opposite operation, which ends up being this. This is the same as sine to the -1. It's actually really cool. And this is something that if you're into those exponent laws, you'll understand why this works. But for those who don't really care, then that's fine as well. So the inverse for cos is cos to the -1, and the inverse for tan is tan to the -1. So you'll see those little symbols or those expressions written somewhere on your calculator. They probably don't have their own button. It's probably something, again, where you have to do a second function or a mode or a shift, depending on how your calculator works. And then you're going to press that button where it's right above it, and then it should show on, if you have a calculator, that will show you what you're entering in. you'll see the sine inverse, and then you can enter in whatever number it is. So again, depending on how your calculator works, sometimes you will have to enter in the angle or the expression first and then press the sine inverse button. Sometimes you'll have to press your sine inverse button first and then enter in your numerical value. You're going to have to play around with yours to see which one works the best. So calculate each of the angles given. So let's take a look at how this works. So in order to isolate for this angle, we have to get rid of the sine on the left-hand side of this expression. And the opposite of doing the sine of something is the sine inverse. So in order to do that, the sine will disappear on the left-hand side. So we're left with just this theta, or this angle symbol. And we're doing the sine inverse now of 0.667. And this is where you take your calculator and you're going to either enter in your 0.667 first, or press your buttons to get the sine inverse and then enter in 0.667. So you should get an answer, if we round to one decimal place in this question, an answer of 41.8. And this is an angle measurement, so we need to include our degree symbol. So please play around with your calculators to make sure that you can get these final answers. If you're running into some difficulties, please let me know and we can work through how your calculator works. So we can use the inverse operations for each of our three trig ratios. So the angle, when we isolate for the angle, we get rid of the cos on the left-hand side. We stick it on the right-hand side, but we do the opposite operation, which is cos inverse of 0.667. And again, using our calculators, we get an answer of 48.2 when we round to the nearest tenth. And that's a degree symbol, so that's an angle measurement, so we have to include our degree symbol. And for tan, in order to get our angle by itself, we have to get rid of the tan on this side, so we're using our opposite operations. So the tan disappears from the left-hand side, and the opposite of taking the tan of a number is taking the tan inverse, and we're going to do that for 0.667, and so the tan of a number is going to give us about 33.7 degrees when I round to the nearest tenth, or the one decimal place. So now that you have some idea of how to use your calculator to solve for that angle measurement, let's talk about some different examples and the 3 steps to solving those angles. So the first thing that you want to do is you want to label the sides of your triangles relative to the angle that you want to find. So always across from your right angle is your hypotenuse. Across from the angle that you're trying to find is the opposite side, and the one beside the angle is your adjacent side. So now I have to look to see which one of these trig ratios I have to use. Well, I know my hypotenuse side, I know my opposite side, and when I think about SOHCAHTOA, well, my opposite and hypotenuse is my sine. So I'm going to take the sine of this angle, and I'm going to use my angle symbol theta, or I could use the letter C to represent that angle as well, is equal to the opposite side, which is 6, over the hypotenuse side, which is 11. So I'm going to go ahead and do 6 divided by 11, and that gives me 0.545 when I keep 3 decimal places. And now I want to get rid of the sine on the left-hand side, so I have to do the sine inverse to my decimal number. And I get a value for my angle measurement. So angle C is going to be equal to about 33 degrees when I do that calculation. Let's take a look at the next two examples here. So first, label your sides. I have my hypotenuse, which is across from my right angle. It's asking me to find angle T. So across from angle T is my opposite side, and beside angle T is my adjacent side. So I need to use my trig ratio that involves the adjacent side and the opposite side, which is tangent. So I'm finding the tangent of this angle, which is the opposite side over the adjacent side. I can either keep this angle symbol or I can substitute the letter T in its place because that's the angle that I'm trying to find. The opposite side measures 4.5, the adjacent side measures 6.5. Use your calculator to do 4.5 divided by 6.5. You get approximately 0.692. And then from here is where I do the opposite of tan or tangent to get rid of the tangent on the left-hand side. So I'm just left with T, and the opposite of tangent is tan inverse. So I'm going to use my calculator to work out that measurement, and I get an answer of approximately 34.7 degrees. So angle T measures 34.7 degrees. And in this last example, again, I want to start by labeling my sides of my triangle. Across from your right angle is your hypotenuse. And it's asking me to find angle M. So across from angle M is my opposite side. Beside angle M is my adjacent side. I have to think about what sides I know. Well, I know my adjacent side is 2 meters. I also know that my hypotenuse side is 3 meters, so I need to use the trig ratio that uses adjacent and hypotenuse, which is cosine. So the cosine of an angle is the adjacent side over the hypotenuse side. I'm going to substitute in what I know for my diagram. The cos of my angle is M, so I can either keep my theta symbol or I can substitute it with the letter that I'm trying to find. So cos of M is equal to my adjacent side, which measures 2, over my hypotenuse side, which measures 3. Use your calculator to do 2 divided by 3. That gives you approximately 0.667 when you round to 3 decimal places. And now we want to do the inverse of cosine in order to get M all by itself. Remember, whatever we do to one side of my equation, I do to the other. So I have to do the cos inverse of 0.667, which when I use my calculator to figure that out, gives me a value of 48.2 degrees when I round to that 1 decimal place. If you have any questions about this lesson, because it can be a little bit tricky when we're first starting out, please let me know. Sign up for a virtual help session or send me an email, and I will see you in the next lesson.